Yes, sir. So, okay, let's solve this paper, summer 2025, 5-1, paper 5. Okay, sir. So, okay, let's see the question. So, this was a thin coil of cross-sectional area A and length L connected to a resistor of resistance S and two terminals. Okay, so an alternating voltage is applied to the terminals. The peak value of the alternating voltage is E. Okay, so it's a peak value of alternating voltage, sir, and the frequency is F. The peak value of the potential difference V across the resistor is determined using an oscilloscope. Okay, now what is happening here is alternating voltage is applied to the terminals. So here, okay, so the peak value across the resistor is measured here. So this is measured using oscilloscope. Okay, it is suggested that V is related by F. Now what we are changing frequency. So that's an independent variable. Because of that, what changes? So F is independent variable. So read the passage. Alternating voltage is applied to the terminals. The peak value of the alternating voltage is E and the frequency is F. Okay, the peak value of potential difference V across the resistor is determined using oscilloscope. So if you apply voltage only, you will get something here. Can you change the voltage without doing anything here? Yes, you can. For example, if you change the resistor, you can. Or if you change the coil, you can. But we are not changing either of this. We are changing only this. Is it clear, sir? So V is dependent. Or we can write vary F and measure V. Okay, sir? Yeah, okay. Now we have addressed one problem. Then, so we have two quantity in this area. One is E, that is peak voltage, E and F. So we are only changing F. So what we should keep constant? E we should keep constant. We'll get into a minute, but I'm just giving you this information. Okay. Now let's take this equation. ES by V equal to KAN square F by L. Okay. Okay, sir. Now, so we have this thing. Now in Y place we should have V, and in X place we should have F. So it's not directly F or V, but some function of V, some function of F. You understand this one? So we have to rewrite that one. Okay, now equation is like this: ES by V equal to KAN square F by L. Right? Yes, sir, sorry. So now just the equation I wrote. Okay. Now it's already E here, but what is extra is E and S. So can I move both here? So 1 by V equal to KAN square by ESL into F. So what is Y interceptor? That is if you have some power or some sin theta or some log or some exponential, then you will get Y interceptor. No, okay, so we'll see one question example for that. Okay, so now we can relate this with Y equal to MX plus C. Okay, now Y interceptor is 0. So the straight line should go through the origin or it should not go through the origin? Y interceptor is 0, sir, meaning it will go through the origin. Yes, okay. So we have to draw a graph 1 by V, volt inverse, F hertz, and the line should pass through the origin. Okay, so if you draw the graph like this, we will get a gradient out of this line, right? The gradient is equal to this part, right? So gradient will be KAN square divided by ESL. Sorry, it's a small L. Yes. For that, it's 1 mark. Okay, sir. Now we have found the gradient. Since okay, yes, sir. Now since Y interceptor is 0, we do not need to worry about it. Now let's just take and list out all the quantities. Okay, so now we have E, S, V, K, A, N, L, F. Yes, sir. Now E is voltage. We can measure using voltmeter or oscilloscope. Okay, S is resistance. So we can measure in ohm meter. Again, this V is voltage, so we can use oscilloscope. Okay, so K is the constant we have to find. Okay, so we have to rewrite this equation in terms of K. Now you just have to rewrite this equation for K. So no need, sir. I'll tell you. So now K is gradient into ESL divided by KN square. K, right? Now A is area of cross section. How you will find area of cross section of a wire? Yeah, so using micrometer and pi d square by 4. Okay, then N is number of turn we can count. L is length of the coil we can measure using ruler. F is frequency that you can measure using oscilloscope. That's all you have got most of the marks. That's it. Okay, but you have to write it in the structure. That's all. How many papers you have done, sir? Until doing 6 or 7 papers, it will look difficult only. Only until like maybe only after you finish 5th or 6th paper, then you will understand. Oh, this is what paper 5 is. Okay, now we have solved everything, sir. We just have to put it in the writing form. That's all. Okay, so now let's see how to put it in writing form. Okay, now let's how to write this question. See, just follow these orders. Procedures to be followed, measurements to be taken, control of variables, analysis of the data, safety precautions to be taken. Okay, you do not need to give it in the exact order. So usually how I will give is control of variables first, measurements to taken second, procedures to taken third, analysis of data fourth, safety precautions fifth. You can have your own order, sir, but you should have some order. Why it is important to have some orders? Then only you will remember what point you forgot, what point you wrote. Okay, so and then we have to give the diagram. So in diagram part, what you have to do is you just first copy whatever is there in the paper given. Okay, now what is given is okay, sir. This is given and this is yes. and this is L. Okay, you have to write all the variables nearby, sir. So V is measured here, S is the resistor, S is measured in ohms. Okay, and so now we have the alternating current. The symbol for alternating current is this, AC, power supply. Okay, wow. So here we have E and F. E is measured in voltage, F is measured in hertz. Okay, wow. The entire thing, okay, we have to connect one more oscilloscope. If you don't know the symbol of oscilloscope, you can just write a diagram, circle, and then write it as oscilloscope. You can put a bar or a circle if you don't know the symbol. Yes, yes. Now, small symbols such as a variable resistor or something is very important, but oscilloscope is not a problem. Okay, the entire thing is electric, right? Yes. So the entire thing is electric. So for safety precaution, what you can do is you can just put an insulation mat. Okay. So if it is something magnetic, then you will put non-magnetic material. Is it clear, sir? Yes. Okay. Now, so now this is diagram. Okay. So what are the marks for the diagram? Is oscilloscope connected parallel with the resistor that you have marked. It's a workable circuit. Oscilloscope and power supply labeled. Okay. So that's all. Oscilloscope connected parallel to the resistor. The side power supply is connected. No, you have to mention. You have to actually write it as a power supply. AC power supply. No need, sir. But for our information only, we are mentioning here. Please mention. What are you going to lose by mentioning it, sir? Yes. Time. Nice, sir. Okay. Okay. So now we have done with the diagram. Now first let's discuss about. Okay, 1 minute. No need, sir. Maybe you can write if you want NA. This is for our information. I'm going to mention it here, sir. Okay. So, sir, must label. You should label everything. Label is very important. Yes. Okay. So, yes. Okay, sir. So first thing is control of variables. So what we have decided, vary F and measure V. Right now. So that's control of variable. In second, measurements to be taken. Right now. So in this we have one nice advantage of the equation. What you have to do, just write the equation. Okay, wow. Write the equation. In this, write everything here. All the variables here in the equation. Okay, watch here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, sir. So each, yes. Okay. You are going to talk 3 things about each. 1, whether they are constant or variable. Second, using what instrument you have to measure it. Third, if there is any formula involved, you are going to write the formula. Yes. Same, whatever we discussed earlier only. Okay, well, okay. So learn how I'm writing. For example, what is E? Sir. E is the voltage here, sir. So E voltage, okay, kept constant. Measured using oscilloscope or voltmeter, anything is fine. Okay, what is S, sir? Resistor. Okay, resistor. Yes, measured using ohmmeter. Yes, you can. You should. Okay. So 4 meter, no problem, sir. Should we keep it constant or variable? No, resistor, constant. Okay. So V is a variable. Measured using oscilloscope. Okay. Confirm with the exam officer, sir. Okay. Okay. Now K is a variable. Sorry, K is a constant. How you will find K constant? By rewriting this equation. Okay, wow. So that equation we will write. So K equal to gradient multiplied by ESL divided by K n square A. Okay, sir. Okay. Now A is should be A keep constant or a variable? We should use the same coil throughout the experiment. So constant measured using micrometer using the formula pi d square by 4. Okay. So n square n. So n square must number of turns should be kept constant. Okay. So F we are varying. Varied. Yes. Varied using oscilloscope / power supply. Okay. So L kept constant. Length of the coil measured using ruler. This one, sir. Actually, that is the main thing that we are doing this experiment for. Okay, wow. So defining A is a constant, we'll get you 1 mark. How to measure it using micrometer, 1 mark. Using what formula, pi d square by 4, 1 mark. So sometimes these marks will be clubbed together or sometimes it will be offered separately. So we don't want to miss anything. Okay, sir. Now these are the measurements to be taken. Okay. Third, procedures to follow. Right now. So now we have to be careful about in this in this line of variables, what are the things that we are keeping constant and how we are keeping constant? Okay, for example, so we have to keep E constant. Okay, so constant E by adjusting potential difference across power supply. Okay, wow. Second, so this is resistance. So resistance, we just have to put the resistance. We do not need to do anything more. Okay, so V variable measured using oscilloscope. A constant using micrometer, right? So this one, A, multiple values are taken and measured average. To find average. D. Okay, sir. So this number of turns and the L constant, we should keep constant, right? So N and L to keep constant. L length of the coil should not vary in the middle of the experiment, right? So coil you can stick it to some board, to the bench or board. Sir, remember when you pass the electricity, it will expand or compress. Then L will vary. You understand, sir? If it varies during the middle of the experiment, will you start doing the experiment from the beginning, sir? L we have to keep the constant, right? Let's say it started roll down somewhere. Yeah, so we need to fix the position so that we make sure that the L is constant. Okay, sir? Yeah. So like this, you can give as much as point you want. You can give, but only top 6 points will be taken for 6 marks. So procedure, how do you make a good measurement out of that one? For example, are you taking multiple readings? Are you using a protractor stand? Are you using, let's say that in case of you want to measure time of something falling, are you using light gate or something? Are you taking the video of the experiment and doing something? Okay, so actually there are more variables controlled in the marking scheme. For example, so in the marking scheme it was given us how to control, how to measure in oscilloscope also, but that is beyond the scope. One or two marks rarely will come, so that we do not need to know. Okay. Yes, and so we are directly measuring ohmmeter, right? This also you can measure using V equal to IR, so R equal to V by A. You pass a small current in the resistor and find the voltage across it. Sorry, you apply a small voltage across it and find the current. Using that you can find the resistance. So all this thing you can do. No, not finally, fourth. Okay. So this is the equation. Yes, sure. Okay, so this is the equation, and we have rewrote the equation in such a way: V equal to KAN square by L in ES into F, right? So we can compare this Y equal to MX plus C. So first so now first we have to tell what graph we have to plot, right? We have to plot whatever in the Y place, which is 1 by V volt inverse measured. Okay. In X place it's F measured in hertz. And since Y interceptor is 0, line should pass through the origin. You have to mark 0, 0. Yes, yes. Okay, so this line passes through origin, you will show only if Y interceptor is 0. Otherwise you will not show. Then you will just in written, I'll give in written. Okay, so we will write. Okay, so now we will write K is, so you have to write gradient or M, but if you're writing M, you have to mention its gradient. Okay, so gradient, gradient equal to KAN square divided by ESL. Yeah, so from this K equal to, this equation is very important. This is the thing that we are working for. Gradient into ESL divided by AN square. Okay, sir. Okay, and you will write relationship is valid only if the line straight line and passes through origin. Yes. Okay, sir. If Y interceptor is 0, then you will simply write it should not pass through the origin. Okay. The last point, safety precautions. Yes. Yep. C0. Yes. Okay. Last safety precautions. Despite of whatever experiment you are doing, please write wear goggles. Yes. Yes, sir. Sir, whether it is 0 or not 0, please draw the axis with unit. If it is 0, then please draw the line through the origin. Okay. Despite of whatever the experiment you are doing, safety precautions is wear goggles. Okay. Wear heat, electrical, proof gloves. Okay. Wear closed. Yes, closed-toed shoes and lab coat for refraining from any spills. Yeah, proof. Yes. And in case of electrical equipment, you can just write switch off the experiment when it is done. Yes. No, sir, all this contains only 1 point. Yes, sir. But sometimes it will be split into 2 marks. If you don't write, you will be unlucky to get the mark. Super. Okay, sir. That's your first question. Is it clear, sir? Okay, let's do second question. Okay. Okay, yes, sir. Okay, student investigates an electrical circuit. The circuit is set up. Okay, so what we have here is battery of negligible internal resistance is connected to a resistor of resistance Z. So here is a resistor. 5 resistors of each resistance are connected in parallel between P and Q. 1, 2, 3, 4, 5 yes. They are all same resistance. Switch is closed. The total current in the circuit is measured using the ammeter. Here we have ammeter. The experiment is then repeated by changing the number of N, okay, of resistors. Each of resistance are connected in parallel between P and Q. So they just increase and decrease the number of resistors, but same resistance. It is suggested that I and N are related by the equation this I and N. Okay, so if you vary N, I will vary. Okay. Okay, now we have to N we are changing, so that should be in X position. I we are changing, that should be in Y position, right? So they gave a graph is plotted 1 by I on the Y axis and 1 by N on the X axis. Okay, so let's rewrite this equation. E equal to I plus Z. Right, try by yourself. E by that's all. Okay, but E is here. We don't want the E here, right? So we should divide the entire equation by E. So 1 by I equal to R by E into 1 by N plus Z by E. Is it clear, sir? If you compare Y equal to Mx plus C, this is Y interceptor, so Z by E. This is gradient, so R by E. You understand, sir? So if you find the Y interceptor, that will be equal to Z by E. If you find the gradient, that will be equal to R by E. E is electromotive force of the battery. Okay. Super. Okay, let's go to the. Is it clear, sir? Yes, sir. Let's go to the second page. Okay, values of 1 by N and I are given in the table 2.1. Okay, 5, 6, 7, 8, 9, 11 is here. 1 by N is also here. Okay, all the I plus or minus 5. We have to find 1 by I. Remember, 10 power 3 is given here. So you should not include 10 power 3 in your answer. Okay, if your answer is 5000, you have to write 5 because 10 power 3 is here. No, sir, I is in microampere. So if you do 1 by I now, you will get 10 power plus 6 only, not minus 6. Yeah, no problem, no problem. Is it clear, sir? Yes, calculate and record values of 1 by I into 10 power 3 ampere inverse, right? So first what we, now I is given in microampere. Okay, so please do 1 divided by 455 into 10 power minus 6. What answer you are getting? So 2.20 into 10 power 3. 10 power 3 is already here. So what you should write? That's all. Okay, sir? Okay, now what you have to be careful about is uncertainty. Okay, for uncertainty, we have to do the general form first. Let's say that you are finding the quantity C. C is 1 by I. Okay, wow. Now I is given in the form of I plus or minus delta I. Okay, wow. Now you have to find 1 by I. So we know that delta C by C is delta I by I, right? But we want only delta C. So delta C will be C into delta I by I, right? Let's say C is the quantity we have to find. This is C, 1 by I. Okay, we know that delta C by C is delta I by I. So we want only delta C, right? So the delta C will be C into delta I by I. C is nothing but 1 by I. Okay, so I we have here. We know that C is 1 by I. So delta C by C will be 1 by I into delta I by I. Okay, so delta C is this. So if you take 1 divided by 455 minus 6 equal to 2.20 into 10 power 3 multiplied by 5 divided by 455. So we get 2.4 into 10 power 1. So we will write 0.024. Is it clear, sir? Yeah. Okay, we'll do from the beginning. So first it's okay. So for first case it's 1 divided by I. So 1 divided by 455 into 10 power minus 6. So you get 2.20 to 10 power 3. So multiplied by delta I, which is 5 divided by I, which is 455. I have excluded the 10 power minus 6 because top in 10 power minus 6, numerator also 10 power minus 6. So no problem. They are going to cancel out anyway. So it will be 2.42 into 10 power 1, but already 10 power 3 here. So plus or minus 0.024. Okay, sir? Same thing for all the other calculation. So 1 divided by 525 into 10 power minus 6. So this will be 1.90 plus or minus multiplied by 5 divided by 525. So we'll get 0.018. Is it clear, sir? So third is 1 divided by 580 into 10 power minus 6 multiplied by, not multiplied by. So 1.72 plus or minus, okay, 1.72 multiplied by 5 divided by 580. So we get 0.014. It's 1.49 into 10 power 1, sir. But here is 10 power 3 in the numerator, right? So we have to change it to 10 power 3. So 1, 2. So 0.014 into 10 power 3. Yes. Okay. So next 1 divided by 635 into 10 power minus 6. So 1.57 plus or minus multiplied by 5 divided by 635. 0.012. Then 1 divided by 685 into 10 power minus 6. 1.46 plus or minus 5 divided by 685. 0.017. 0.107. Okay, I have to check this value. Yeah, I'll check this value again. 685 minus 6. 685 minus 6. Yes. Yeah, 1.46 multiplied by 5 divided by 685. So 0.010. Okay. Actually, next digit is 7. So we can round it up to 0.011. Next digit is 0. It's 1.07, right? Yes. 1 divided by 765 into 10 power minus 6. 1.31 plus or minus 5 divided by 765. 0.0. Sir, this is 10 power 0. So 0.008. Okay, sir. Hello? Because it is 10 power 0 here. Earlier it was 10 power 1, so it's 0.01. Now it is 10 power 0. So 8.54 into 10 power 0. So to convert into 10 power 3, we have to write 1, 2, 3. So 0.08. Yes, sir. Is it clear? Yes, sir. Okay. Now let's plot the graph. Okay, sir. So it's done. All this work only for 2 marks, sir. Yes, sir. Yes, sir. Yes, sir. Okay. Yes. Okay. So the next step is plotting the graph. Okay, wow. So plotting the graph is very irritating. Okay. So you should keep the value side by side. Okay, sir. Okay. So actually, so if I am writing exam, what I will do, I will copy the value in additional sheet and I will write. Okay. If you're uncomfortable opening both pages in the exam hall. Okay. So yeah. So 1 by n and 1 by I into 10 power 3. Okay, wow. So it's 0.200, 2.20 plus or minus 0.024. 0.167, 1.90 plus or minus 0.018. You will see it in a minute, sir. 1 minute. 0.143, 1.72 plus or minus 0.014. 0.125, 1.57 plus or minus 0.012. 0.111, 1.46 plus or minus 0.011. 0.090, 1.31 plus or minus 0.008. Okay, sir. So why I have copied it? Now it is easy for me to look at as x and y value directly. You can get an additional sheet and write it and then strike it later. Who's going to ask? Yes, sir. Okay. Okay, first let's mark the values. How to mark a value? Okay, 2 things important, sir. First, you have to figure out what is each line is in y-axis and x-axis. Okay, so in y-axis, it is obvious that it's 2.3 and 2.2. So it will be 2.3 minus 2.2 divided by 10. What you will get? Yeah, 2.3 minus 2.2 divided by 10. Okay, well. So we'll get 0.01. So each line is 0.01. So 2.2, 2.21, 2.22, 2.23, 2.24, 2.25, 2.26, 2.27, 2.28, 2.29, 2.3. This is how you have to count and confirm. Otherwise, you will misplace the points and you will think that it's out of trend, but they are not. Yes, yes, yes. Okay, so here we'll take 2 points. So let's take 0.101, 0.08. 0.10 minus 0.08 divided by 10. Okay, 0.10 minus 0.08. Oh, sorry, 0.10 minus 0.08. Right? Yeah, divided by 10. So 0.002. So each point is 0.002. Okay, so 0.002. Here it is 0.01. Right? So how does this will increment? 0.08. Okay, 0.082, 84, 86, 88, 0.09, 0.092, 94, 96, 98, 0.10. Is it clear, sir? Yes. Okay, now we'll mark the point. First, 0.200 in 1 by n. So 0.20 here is here. Okay, so actually you should use the pencil and this method will be okay. Now this is 0.20. So, sorry. Pen, sir. But now you use pencil, okay, because we want to refer. Okay, now this is 0.20 versus 2.20. So 2.20 is here. No need, sir. Okay, so where these 2 points mark here. Sir, those things are not important at all. You can do it in anything. Yes. Then why you are asking again? You can do it in pencil or pen, anything, sir. But I suggest you do it in pencil because if you make some mistake, you can erase it and redo it. Before submitting the paper, if you want, you can write in pen. Not a problem. Okay, sir. Yes, sir. Okay. So next point is No problem, no problem, sir. Next point is 0.167, right? Now it's 0.167. Okay, now we have 0.16. Remember 0.162, 164, yeah, 164, 166, 168. Okay, so it's between 0.166 and 0.168. Is it clear, sir? Yeah, so, but we do not know whether it is 167 or 168. So what we can do, we can go to the previous page and check this calculation. So it is 1 divided by 6. So it is 1.66, 0.16. That's why they have rounded into 0.167. Okay, so it's 6666 value, 1.66. So you can mark it in 0.166, 0.162, 164, 166. You understand, sir? Versus 1.90. So 1.90 is here. Okay, yes, sir. Okay, now third point is 0.143. So 142, 143, 144. So we'll mark it 0.144. Okay, wow. Versus, so okay, so before the second point is this. No, no, not this one. 1, 2, 3 third line. 1, 2, 3 third line is this. Okay, so this is 0.166, 1.90. Okay, it should be visible, clearly visible, but it should not go through any adjacent squares. That's all. The dot is preferred. And make sure. Yes, sir, no problem. Okay, put a dot. No, put a dot. Put a dot. Okay, so okay, now it's 0.144 versus 1.72. So we have 1.7, 1.71, 1.72. So 0.14, 1.72. Sir, do you understand why I'm marking inside? Because I want to refer which point is which. Okay, so next 0.125. Okay, 0.125 belongs to 1 by 8. So I think it is exactly 125. 1 divided by 8, 0.125. Okay, so 0.12, 122, 124, 126 between these two. Okay, so 0.124. Okay, so this side it is 1.57. So 1.5, 1.51, 52, 53, 54, 55, 56, 57. 1.57. Okay, sir. So 0.14 second line, 1.57. 0.124, 1.57. Okay. So when we mark the lines, we should see that whether they fall into straight line or not. If they're not falling into straight line, we have to double check the reading positions. If positions also checked, they're not right now, we have to go back to the reading and check them. Most probably we made mistake. Questions will be correct. Okay. Okay. So next is 1.46. No, never. There is not a chance that question is wrong. Okay. 0.111. So we have 0.10. So 0.11. 0.11. So okay, we'll mark it here. 0.111. Okay. And 1.46. So 1.46 is here. 1.46. Finally, what we have? 0.090. Okay, here. 1.31. So 1.3, 1.31 here. 0.090, 1.31. Okay, sir. Now, do you understand why I draw in another paper? Because I don't have to move this graph paper at all. So it's very convenient for me and not misleading. Because I don't have to move this paper like this. So I know what is the count of each line. So I'll just minimize the error of me marking accidentally in some other place. Okay, wow. Yes. So now we have uncertainties in y intercept, y line, y axis, right? So what we have to do? What is the minimum value in y axis? 0.01. Okay, see. 2.3 minus 2.2 divided by 10. So 0.01. Okay, sir. Hello. So what you have to do? Yes, sir. What you have to do? Divide this by this number, each value. Okay. 0.024 divided by 0.01. 2.4. Okay. Always round it. Okay. So let's write 2.4. Okay. 0.0. So this is 2.4 means that if this is the point, then you have to 1, 2, 3, 1, 2, 3. So you have to go 2 points, 2.4 times up, 2.4 times down. Do you understand, sir? So you can round it up to 3. Yeah, but it is uncertainty, sir, error bar, so we can round it up to 3. Okay. When it comes to error bar, it should be symmetrical. Okay. Only this line is considered as error bar, not this gap. Only this line is considered as error bar. Okay, wow. Your line should pass through this, not this line or this line. Is it clear, sir? Okay. So now it is 2.4. So 3 lines up and 3 lines down. Okay. Then 0.018 divided by 0.01. So 1.8. So 2 lines up, 2 lines down. Okay, so next is also 0.024. So until end it is two lines. So two lines up, two lines down, two lines up, two lines down. Come again? Yeah, it's fine because it's a small line. So I accidentally gave 3. See, I accidentally gave 3. It is wrong. No need. Fine. Yes. So last one is only one line, but you can give it to 2. Okay, why? Because one line, if it is one line, it will be very difficult to draw. Okay, sir. Now you have yourself a good graph. Okay. Now what is the best fit? Best fit should pass through all the middle of the error. Okay. So best fit. This is the definition for best fit. Okay, wow. Should pass through all error bars middle of all error bars. Okay. Yes. For example, if lines are like this, it should pass through. Try to pass all middle. Okay. So worst fit is this one now. Yeah. This is not considered as error bar. Only vertical is considered error bar. Okay. So adu chumma maybe you can call it cap. Yes. It can, but if it touch, you cannot consider that as touching error bar. It means that your line is out of the error bar. Okay. So now this is best fit. Okay. Now worst fit is either bottom of the error bar of bottom point to top of the error bar in top point. You understand, sir? Or top of the error bar in the bottom point or bottom of the error bar in the top point. So this will cross. No. If it goes like this, it's fine, sir. It's touching both the stem and the line, it's fine. But if it goes like this, it's not fine. It should touch the error bar. Okay, sir? Yes. Okay. Now you must take 30 centimeter ruler into the example, otherwise you will face a problem what I'm going to face. Can you see? I cannot find. So I cannot find a perfect trend line with this 15 centimeter ruler. Can you see, sir? Super, sir. If a person takes 15 centimeter ruler to the exam, he will score only 15 marks out of 30. Okay, 30 centimeter ruler, 30 marks. 1 minute, sir. I'll search for the 30 centimeter ruler. Yes, sir. I found the ruler from Nelly garbage. Okay. Okay. Yes, sir. So now I'm going to use green pen to best fit. Okay. Wow. Sir, can you see that I have draw the line in such a way that it is touching all the error bars? Okay. Mostly in center. Yes. Okay. So we can actually mark LOB. F. Okay. Wow. Yes, sir. Yes. You cannot do like that because it has error bar. So our line must pass through the error bar. Okay. So now let me try that. Yes. Exactly. I see. That's okay, sir. Super. Okay. Now best fit I'm going to draw like this. See. So this is line of worst fit. Okay. Wow. Sir, conditions for best fit and worst fit. They should cross each other. They should not be parallel to each other. Okay. Wow. Most people think that they draw a line parallelly out of the gradient. So it is worst fit. No, it's not. Line of best fit and line of worst fit must cross each other. It is still a fit. You can't touch the cap, sir. But it must touch the error bar. Okay. So both the line of best fit and line of worst fit all must touch all the error bar. Okay, then. So line of best fit and worst fit. Sir, worst fit does not mean that this is a worst fit, sir. This is the steepest or shallowest fit we can draw. That's all. Both, you will know, sir. Both should pass through all the error bars. Okay, and they should cross each other. Should not be parallel to each other. Okay, sir. Okay, sir. I have drawn the line such a way that it has gone extend out of the graph page, right? So I have two benefits. I have two benefits from this drawing extra. Okay, so first let me mark those points. Okay, so for line of best fit, I'm marking this point. Okay, so that is okay. Sir, I want to find out this point. Okay, wow. So it's actually seventh line. So it will be 2.20, 22, 24, 26, 28, 30, 32, 34. So 0.234. Okay. Yes, sir. Actually, we have to find gradient of both lines. You will see it in a minute. Okay, so it is 0.20, 202, 204, 206, 208, 201, 2012, 2014. Okay, 1618, 2014. Yeah, 2014. It's not 2014, 214. Okay, sir. 0.214, seventh line. And is 2.3 into 10 power 3. This 10 power 3 should not forget. Okay, so best fit this line is 0.214 into 214 comma 2.3 into 10 power 3. Okay, sir. So for worst fit, it is, I'll take the second point. Same 0.2141618 comma 2.3. Is it clear, sir? One point on the best fit, one point on the worst fit. Okay, here also I'll do the same. For best fit, I'll take this point 0.08 comma 1.2, 1.21, 1.22. For worst fit, I'll take this 0.08 comma 1.25, 1.26. Okay, sir. So now MB meaning that best fit. I did see line of best fit and line of worst fit. So we have to do, sir. We have to do. I'll do it. Okay, sir. For line of best fit, I'm taking 2 points. Okay, which are 0.214 and 2.3 into 10 power 3 and 0.08, 1.22 into 10 power 3. Okay, this two I'm taking for line of best fit. Line of worst fit, I'm taking 0.218, 2.3 into 10 power 3. Down I'm taking 0.08, 1.26 into 10 power 3. Is it clear, sir? Yes, sir. Obviously, you have to draw the triangle. Please do not forget to draw the triangle. Try that. Okay, look how I'm drawing the triangle. So for line of best fit, it should be here. Actually, in paper 5, you do not have mark for drawing the line of drawing the triangle, sir. Why you want to take this car? Okay. They won't ask, sir, but who knows? Someone, maybe new director appointed for marking scheme. He'll say, put the triangle mark on. What will do? Super, sir. I think we should put you in a state board or CBC. Then you will understand what is the real difficulty. Okay, two triangle. Okay, sir. Okay, sir. First, let me find the best fit. Okay, so two. So I'm going to use MP. Okay, so x1, y1, x2, y2. Okay, sir. I have to do y2 minus y1 divided by x2 minus x1. So 1.22 minus 2.3 into 10 power 3. This 10 power 3, most of the people will miss, sir. That's why they will do mistake. Super, sir. Okay. It's 0.08 minus 0.214. Make sure that x-axis doesn't have any unit. Sorry, any 10 power 3 or something. Y-axis or 10 power x-axis. Okay. So now if you do it, 1.22 minus 2.3 multiplied by 10 power 3, which is 1000, right? Divided by, why I didn't put 10 power 3? Because answer multiplied by 1 multiplied by 10 power 3 we have to put. If you directly put 10 power 3, it will show syntax error. Yes. 0.08 minus 0.214. So we get 8059. Okay. So we get 8059, or we can write it as 8.06 into 10 power 3. Okay, sir. Now unit. X-axis unit is, sorry, y-axis unit is ampere inverse. X-axis doesn't have unit. So this also have the unit of ampere inverse. Is it clear? Okay. Now we have to find line of worst fit. Okay. So using same x1, y1, x2, y2. Okay, sir. So 1.26 minus 2.3 into 10 power 3 divided by 0.08 minus 0.218. Okay. Yeah, you can. Okay. So what I'll get is 7536 or 7.53 into 10 power 54. We can write 36. So 7.54 into 10 power minus 3 ampere inverse. Okay, sir. So now line of best fit value is this 8.06. Okay, then you have to directly write line of best fit 8.06. You have to write plus or minus, right? So for plus or minus, you should subtract the difference between these two values. Whether they are plus or minus, you will just write the difference between these two values. Okay. So 8059 minus maybe 10 power 3 we took. So we'll write 8.06 minus 7.54. Okay, sir. So 0.052 plus or minus 0.52 into 10 power 3 ampere inverse for 2 marks. How is it? Yes, sir. So we'll mark down this best fit value as 8.06 into 10 power 3. Sorry, 8.06 plus or minus 0.52 to 10 power 3. Okay, line of worst fit is 7.54 plus or minus. Okay, this we do not need into 10 power 3. Okay, sir. Okay, then we'll move to next page, last page. Then in the last page, sir. Okay, determine the y-intercept of the best fit. Include the absolute uncertainty in your answer. So for y-intercept, we have to use y equal to mx plus c. So c equal to y minus mx. Okay, so for first we'll line of worst best fit y-intercept. We'll take the same point. Okay, so best fit can take any point. I'm going to take this point. Okay, sir. So we'll take. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Absolutely. Okay. So C of best fit. Okay, C of best fit will be, so y value, which is 2.3 into 10 power 3 minus x value 0.214 into gradient value 8.06 into 10 power 3. Okay, sir. You can in paper 5 you can solve any question in your as you like. Okay, minus 0.214. Sorry, sir. Okay, so 575 into, so okay, we'll see. So 5.575. So if you put it into 10 power 3 now, into 10 power 0, so then 1, 2, 3, 0.575. So we have to check if it goes with the graph. 0.5. I don't think it goes with the graph. Okay, we'll check if there's anything wrong. Y minus mx. So 2.3 into 10 power 3. X value is 0.214. Multiplied by gradient is 8.06 into 10 power 3. So 2.3 into 10 power 3 minus 0.214 into 8.06. 8.06. Yes. 10 power 3. 575. Okay, so we'll get 0.575 into 10 power 3. Okay, sir. Yeah. Then for post fit also we'll do the same. C of post fit. So we'll take same one y value from any of these two. I'll take this one. 2.3 into 10 power 3 minus x value 0.218 into post fit gradient is 7.54 into 10 power 3. Sir, but you have to make sure that you're not committing any mistake. Otherwise, you will lose mark. Okay, so this is 0.065 into 10 power 3. Maybe 6 we can write. Okay, sir. So now the difference will be 575 minus answer. So 81.2. Okay. 575 minus 656. 81. So 0. So if answer difference is 81, so we have to write into 10 power 3. So you have to 81 divided by 1000 now. We'll get 0.081. So we can write 0.58 plus or minus 0.081 into 10 power 3 ampere inverse. Okay, sir. Super. Okay, the last part. EMF of E of the battery is determined twice. Ampere inverse is just whatever the unit of the Y axis unit. Okay, so one more thing also you can do is you can just extrapolate the graph. Now here it is 0.1 now. So this distance. And if you take this distance, Y will go here. So it is approximately this value 0.5. So approximately you can just take a look in the graph. Okay. The values of two values 5.6 and 6 value. Okay. So we have to find what is R, what is Z. Okay, so two values are found for V. So how we will take the average? We'll take average. So 5.6 plus 6 divided by 2. So it will be 5.8. I think. Yes, I'm right. So E equal to 5.8 volt. Okay. Plus or minus 0.02 volt. No, 0.02. Yes. 0.2, sir. 0.2. So 5.8 plus or minus 0. Actually, it should be 0.1 because it's range divided by 2. Okay, so that we will lower later. Okay, wow. Now it is 5. Equal to 5.8 volt. We have to find R and Z. We know that gradient is R by E. Okay, so M equal to R by E and Y interceptor C equal to Z by E. Right? So R will be gradient into E. So gradient value is 8.06 into 10 power 3 into 5.8. So it is 4.675 into 10 power 4. So it's a resistance. So it should be ohm value. Okay, wow. So I can write it as 46 kilo ohms. Okay. So R is ohms. Okay. If you don't know whether it's ohm or not, you know gradient unit is ampere inverse. Okay, multiplied by this is voltage. We know that V equal to IR, R equal to V by I. So this is also V by amperes. So it is ohm. Okay, sir. So second, we know that C equal to Z by E. So Z equal to C into E. So 0.58 into 10 power 3 into 5.8. Okay, wow. So 5.8 into 0.58 10 power 3. So I'll get 3.36 into 10 power 3. Yes. Okay, so this is 3.3 kilo ohm. Okay, sir. So 46 kilo ohm, 3.3 kilo ohm. Is it yes, sir? Okay. Determine the percentage uncertainty in your value of R, right? So R we found using this formula, R equal to M into E. So now delta R by R into 100% will be delta M by M into 100% plus delta E by E into 100%. This is the full formula, but problem is we do not know delta E. Okay, so we know that it is 5.8 plus or minus 0.2. E value. Okay, so we will figure out delta R by R into 100% will be delta M. Okay, wow. Delta M is 0.52. 0.52 divided by 8.06. Sir, both of them are 10 power 3, so they will cancel out each other. Okay, wow. Plus 0.2 divided by 5.8 into 100. Yeah, but they will cancel out each other, so no problem. Okay, so 0.52 divided by 8.06. So this is 6.4 into 10 power minus 2, this one, plus 0.2 divided by 5.8. So this is 3.44 into 10 power minus 2. Okay, wow. So I'll add both plus 6.4 10 power minus 2. So 9.8 into 10 power minus 2, right? I have to multiply by 100. So I will get, it's not 500, sir, into 100, sorry, 100%. So 9.8%. Okay, I don't, sorry. Sir, it's actually 9.9, sir. No. See, how I did is I did like this. I open a bracket, I put 0.52 divided by 8.06 and close the bracket, plus again open the bracket, 0.2 divided by 5.8. So into 100. So this way it's very easy. So 9.9%. Okay, sir? Now because we want to find the percentage uncertainty in R. The full form of percentage uncertainty in R is delta R by R into 100%. Is it clear, sir? You won't multiply by 100%. The answer you will not multiply by 100%. That's all. We know the difference between percentage uncertainty and absolute uncertainty is only multiplied by 100%, right? Yeah. Is it clear, sir? Okay, super. So the last part, the experiment is repeated with 20 resistors. Each of resistors are connected in parallel between P and Q. Determine the total current in the circuit, right? So for that, we have to bring the first equation. So just rewrite this equation for I. Okay, so I will be E divided by R divided by N plus Z. Okay, sir? So I'll write here. So I equal to E divided by R by N plus Z. Okay, so I equal to E divided by R by N plus Z. Okay, wow. So 5.8 divided by R is 46 into 10 power 3 divided by N is 20 plus Z is 3.3 into 10 power 3. Okay, sir. So we can take the 10 power 3 out. So 5.8 divided by 46 by 20 plus 3.3 into 10 power 3. Okay, sir. So 46 divided by 20 is, I think, 23. 0.23. Yeah, 2.3. So this is 2.3 plus 3.3 is 5.6. Okay, wow. So it is 5.8 into 10 power minus 3 divided by 5.6. 10 power 3 goes in the top, so it becomes 10 power minus 3, sir. So 5.8 into minus 3 divided by answer 1 milliampere. Yeah. So so I'm getting 1.036 into 10 power minus 3 ampere. Okay, let me recheck the value. So 46 divided by 20. So 5.8 divided by 2.3 plus 3.3 into 10 power 3. Okay, wow. Plus 3.3 into 10 power 2.3 plus 3.3 into 1 to 10 power 3. See, if we directly multiply answer with number 9, it gets syntax error. 5.6. So, yes, sir. 5.8 into minus 3 divided by 5.6. Yeah, so it's right. So 1.036 into 10 power minus 3 ampere. Okay, wow. So how we can check is in the trend if yes, sir. Okay, sir, watch here. So for 20, we are getting I this much. Okay, wow. So it is actually 1036 into 10 power minus 6 ampere. So just 1036 microampere. Right up. Watch it in the graph. As n increases, current increases. Can you see? For 5 it's 455, for 11 it is 765. So if you extrapolate, for 20 it can be 1000. So we are in the right path. Is it clear, sir? Super, sir. Sir, please do not worry about significant figure in paper 5. Okay, if you try to round off, you will end up in big confusion. Yes. Is it clear, sir? Yes, sir. How long we are solving 2 hours, sir? Yes, sir. Do you have any doubt in this one, sir?